Okay, so we continue to this. Now, for this example 13, I have to find the interval. Okay, I have to find the interval so that this CDF for this kernel density by using uniform, okay, by using uniform that I state as U here, and compared to the kernel density for this distribution, okay, by using triangular that I put this triangle notation. So when this equation for this kernel distribution equal, okay, when these two equal, so what is the interval will make this equation equal? Okay, so based on this data, so here we go.
Example 13. You are given this sample 1, 2, and all these 3. So let Fu is the kernel density estimator of the distribution function using a uniform kernel with this bandwidth is 1. And next we let this F triangle is the kernel density estimated of the distribution function using triangular kernel with bandwidth is 1. So our aim is to find the interval when this distribution equals to this distribution. This is a solution for example 13. So we let XU is uniform distributed in this range where the bandwidth is 1, and this X triangle is triangular distributed with this interval, and the bandwidth is 1 as well. So from the data given, this is 1, 2, 3. This observation 3 is repeated 8 times. And for this observation 1 and 2, each of these has only one value. So this is a probability that is 1 over 10, 1 over 10, and this is 8 over 10. So let's calculate the kernel distribution for this K under this uniform. So we have to use this formula to calculate. We substitute the B as 1 and X remain, and Xi is become 1, 2, 3. So for this question here, this is my X1 is 1, and this X2 is 2, and this X3 is 3.
Okay, class. Here you have to highlight because this K1, K2, K3. So some students may think that this is just a note, just a reference number for the K. No, this one actually is our data. Remember, the formula actually is for KXI. Okay, somehow just XI is 1, X2 is 2, X3 is 3. Just coincidence. So you may mistaken that this K1, K2, K3 is just a reference number. No, in fact, it's not. This one is our data. Okay, so our X1 is 1 and so on. Okay, please do not mistaken. So all our Xi now is become 1. So remember just now the example, we make our piecewise function in terms of Xi. And now this piecewise function in terms of X. Because you substitute your Xi value, okay, is another method, another format from compared to the example 12 just now. Okay, here we go.
So therefore, I'm going to substitute my Xi as 1, 2, 3, B is 1, and this kernel distribution is in terms of X. So based on these 3 range intervals here, I will have this. So when you simplify, you will have the first one. And similarly, when you substitute X2 is 2 and the B is 1, based on the intervals, you will have this result and this also.
Okay. Okay, so because to save the time, I don't write all this, okay? So to get all this result, I just substitute all my xi value inside to the formula. Then you will have the following result. Okay, so we have a 3 piecewise function here. This is referred to the x1, x2, and this is x3. Okay, and we have a different interval. Okay, carry on.
So from these three k values here, I would like to find what is this kernel smoothed distribution function, and based on this uniform.
Okay, you hold on. I try to recall something. Maybe in my last semester, I think I couldn't recall. I think I check my slide first. You hold on. Okay. Well, I don't know why. I think I didn't complete this video this last semester. So maybe here I need to explain by Word document the following. Okay, so we have about 30 minutes, I think more than enough. Okay, let me take out my notes first. Give me 1 minute. I can't recall. Maybe I have that time I don't have time to complete the video. It's not easier to edit the video, to take the video. Last semester I really spent a lot of time. So okay, let me share you this. Okay, so I hope you can see this Word document that we have stopped at here just now. So can you see this Word document before I go further? Let me check from my. Okay, it's confirmed. You can see this. Okay, now I continue. Just now we stopped at here, my video clip. Okay, and next I try to go to this triangular. Okay, so this is my XU. Okay, and then okay, before I go to this triangular, okay, let me settle this this one first. The smoothed kernel distribution at based on the uniform. Okay, so of course you know that this is a formula. Okay, that's you take the probability, multiply all the values here, x1, x2, x3. Okay. Now, when you multiply, you have to know that this probability P1, and multiply the first k value that is here, okay, and of course so on. But when you sum up, you have to take note that your range must be equal, because all the interval are different. Can you see? Okay, different. So you have to make to the common interval first. So from this 1, 2, 3, 4, 5, 6, 8, 9. So all these 9 interval, I have to split out or break into the more intervals in one piecewise function. Okay, there's 0 to 1, 1 to 2, 2 to 3, 3 to 4, and more than 4. That is here. Okay, so that I have covered all the interval inside here. Okay, so now you can see whatever x is less than 0, that I will take this 0, and this one also less than 0, right? And this one also less than 0. I mean whatever x, what x is less or equal to 0. Okay, so I hope you get it. Okay, I have to make into the interval x is less than 0. So I have a 3, 0 here. Okay. Now, next I go to 0 to 1. Okay. So if a 0 to 1 here, of course, this piece will be considered. That is your here, right? X over 2. Okay, x over 2. And whatever in this interval, okay, is from 0 to 1, for the second piecewise function here, that is 0. Okay, 0. So for the third piecewise function here, in this interval 0 to 1 is still 0. Okay, therefore the second piece is x over 2 plus 0 plus 0. Okay, so let me go to the third piece, 1 to 2. Okay, 1 to 2. So when it from 1 to 2 is still second piece, that is x over 2. I hope you get it. Okay, whatever you choose value from 1 to 2, okay, because this is overlap, this overlap. So whether it's still the same, you pick any because same into, because I told you just now, because it's continuous. Okay, you choose this piece or that piece, you get the same result actually. Okay, so when x is between 1 to 2, the first piecewise function is still this piece, that is x over 2. Okay, so now we go to the second piece. So from 1 to 2, then the second piece will reach to this piece. Okay, here. Now, if you go to the third piecewise function here, for the range 1 to 2, can you see my cursor moving? Okay, I hope you can see. Make it larger. Okay, so if you choose 1 to 2, okay, yeah, you can see the cursor moving. If you choose 1 to 2, for this piecewise function here is still in this range 0. Therefore, you have 0. Okay, so I try one more time. Okay, let's say I choose 3 to 4. Okay, let's say I choose 3 to 4. So when 3 to 4, if you choose your x is 3 to 4, that means this will be forced on this. For the first piecewise function, will be forced on this group, because if you choose x is 3 to 4, so the 3 to 4 is more than 2. Then you have to choose 1. Okay, I factorize 1 over 10 class. I factorize 1 over 10 here. Okay, for the third piecewise function, you have to multiply the 8. Okay, if you have to multiply 8, I hope you understand. Okay, I factorize 1 over 10. The 8 remain inside. Okay, this 8 remain inside. So look at the second piece. If I choose in between 3 to 4 here, then this is forced on the third interval. Okay, so that is 1. Okay, so it's a 1 plus 1. Okay, again, from x 3 to 4, okay, then this must be here. For the third piecewise function here, 3 to 4 is forced on this second interval. So I will choose x over 2 minus 1. And of course, you multiply 8 because I told you just I factorize. Okay, So whatever x is greater than 4, definitely all over the range x. So I will take 1 plus 1 plus 1 and multiply it. So it's here. Okay. So I hope you get it. Okay. This is long working, yeah, because here you have to split out to many interval so that you have a common interval for these three piecewise functions. So next you try to simplify, so you have this result. Okay, so I have settled the uniform. Okay, let's go to the kernel. Then for the triangular. Okay, so triangular, of course, same that if you have to refer to this formula. Okay, you have to refer to this formula. So again, I'm going to substitute my xi inside here and the interval as well. So our xi is 1, 2, 3, right? You substitute like just now we have done for the uniform. Okay. So next you will have this. Okay, you will have this. So remember, this is my x1, this is my x2, and this is my x3. I don't know why upside down here. It doesn't matter. So once you substitute all the xi value, then you will have three piecewise function in terms of x. And again, you have to rearrange the common interval to become like just now. Right? So you first of all you have to multiply first. Okay, you have to multiply from this formula. You have to take the probability multiply the k value. Okay, so you have to sum up three piecewise function. Okay, so this three piecewise function also give you the different interval. So before you sum up, you have to convert to the common interval first, so that all the piecewise function can be submitted, can be summed up. Okay, so now look at the like just now class. I believe you know how to calculate. Let's say I choose the second interval. So the second interval, wherever x is between 0 to 1, okay, then very obvious I will choose this result. That is x squared over 2. Okay, from 0 to 1, that must be this result 0. Okay, the first result 0. For the piecewise function, again must be 0 again, because whatever 0 to 1 is still less than 2. Okay, therefore this is 0. Okay, so you have this result now. This result. So similarly, let's say, remember I also factorize. Here I factorize, then the 8 will remain inside for the third piecewise function. So let's say I pick this 2 to 3. Okay, so whatever x is in between 2 to 3, then you can see the first piecewise function will give me this. Okay, then I will have this result. Right? Here you have to make it smaller first. Okay, 2 to 3. Okay, from 2 to 3, I will have, now you see, class, 2 to 3 is overlapping, right? Either you choose this piece or this piece is the same, still 1. I hope you get it, right? You can see this, if I choose 2 or maybe more than 2. Now, if you choose 2, then will be this. This is still give you the 1 actually, because your 2 minus 2 is 0, so you have 1. So if you choose 2 point something, then you will have 1. So no matter how this is, the first piecewise function will give you 1. Okay, and here very obvious for the second piecewise function 2 to 3, you will have this result. That is here. Okay, and again for the third piecewise function here 2 to 3, you will have this result times 8. Therefore, it's here. I believe you know how to solve this problem, but maybe you just panic or confused. What happened is overlapping. No worry, class. You choose any piece. If you can check and see if you choose x is 1. Okay, x is 1 is false on this group or this group, right? So if x is 1, your answer is x squared over 2. You put your x is 1 here, you still get x squared over 2. You can try and see. You get the same result because this is continuous. Okay? Right? Now, let's go to, once you have this already, class, you simplify, you will have this, right? So I'm going to compare this result. Let me copy. Okay, this result is from the triangular, okay? So I want to compare to the uniform. Just now we have found this, right? Uniform. Okay, so this is from the uniform and this is from the triangular. So if these two results equal, so which interval for the result? That you can see the interval is come from the first interval, that is when 0 equal to 0. So we have this answer, x is less than 0. The second, no. Third, yes, right? For the third line is equal. This equal. So they mean this 1 to 2 also a result. And the next no more, but the last one, yes, 1 equal to 1. Right? So that means when this equation equal, we have 3 interval give the equal range. Okay, that is x is greater than 0, 1 to 2, and x is smaller than 4. Okay, so this is way how we calculate our class. Okay, so it's already more than, now it's already after 12 p.m. already. I have done a class for this chapter 2. Okay, next week we'll go to chapter 3. Okay, so that's it class for today lecture. Do you have any questions?